phosphate salts. They are one of the more common pollutants, and in this experiment, we're going to figure out how to deal with them. Now, before any of you go down into the comments and say that you don't use fertilizers every day, I would like to point out that you would if you have any plot plants. Now, the improper disposal of these fertilizers might cause some unpleasant problems, such as this one. Hey bro, so I have some spare fertilizer that I don't really need. Should I just throw it in? Yeah, why not?
Meanwhile,
why did I ever think that was a good idea? Now, for the experimental principles. We only need to prove a point, which is investigating the practicality, so we don't actually need to repeat the experiment. As for chemistry involved in methodology, well... Anyway, we're going to use potassium and sodium phosphate, and also calcium and magnesium chloride. In case anyone's wondering, calcium chloride is often used for de-icing or dust control on gravel roads, and magnesium chloride is usually sold as supplements. So you should be able to find them in the local grocery store. There are two parts of the experiment, both of which uses 500 milliliters of water. For the first part of the experiment, we decided to use sodium phosphate to simulate excess fertilizers dissolved in water. After we dissolved everything, we decided to add calcium chloride into the solution, and instantly, white precipitate can be seen to be forming. Right now, the sodium phosphate is reacting with calcium chloride to form sodium chloride and insoluble calcium phosphate, which is basically what makes up bones. Now, since filtering everything will be a nightmare, we just waited until the next day when everything just sank down to the bottom, which can be then filtered fairly easily. The magnesium phosphate part went about the same, except when the solution came over, it went a little bit cloudy in the end. But then we just put 2 layers of filter paper and everything became clear now. So in the end, we got 2 solutions of sodium and potassium salts, and also a bunch of sediments. All the products should be biodegradable and also unusable by algae to growth, so it should be fine. So the question remains, is there a cheap and efficient way to deal with phosphate pollution? And the answer is a definite yes.